In 12.3, we're looking at a new part of our circles, and that would be inscribed angles. So a couple objectives. We're going to find the measure of these inscribed angles. We're also going to find the measure of angles formed by a tangent line and a chord. So first of all, if we're going to use inscribed angles, we should probably define them. So an angle whose vertex is on the circle and whose sides are chords of the circle is what we call an inscribed angle. So an arc with endpoints on the sides of the inscribed angle and its other points in the interior of that angle, we call that an intercepted arc. So basically what that's going to look like, your inscribed angle here would be angle C. Again, the vertex is on the circle itself, and our chords make up the sides of that angle. So two chords, BC and AC, and vertex at C, that's going to be an inscribed angle. An intercepted arc is just going to be basically the part of that circle you can imagine that angle is going to be cutting off. So from A to B, that would be our intercepted arc between those two endpoints. And we have a theorem that goes along with those parts. The measure of an inscribed angle is going to be half the measure of the intercepted arc. So if I had angle B here, and if I had arc AC, the measure of angle B is going to be half the measure of that arc AC. Remember, arcs can use both lengths and measures. We're referring to the measures here, so this will be in degrees. We're going to try that with some practice. We're going to try and find the values of A and B, two missing variables from this. So the rule that we're using is just that rule that we had above, the inscribed angle for trying to find A, for example. A would be the intercepted arc that's being used from this inscribed angle of 60. 60 has endpoints at P and T, which is the two endpoints for that same arc that A is measuring. So if I'm using our rule from above, the inscribed angle is 60, that's half the measure of that intercepted arc, which is A. So if I work my way a little bit backwards, if I multiply both sides by 2, I find that the intercepted arc was 120. And we can also check half of 120 gives us the angle, that would be 60. And now that we know A, that's going to help us solve for part B. B is just looking for the inscribed angle this time. So if I use my previous answer that A was 120 degrees and add this extra 30, that would be our entire intercepted arc for angle B, going all the way from P to S. So if I add those two together, that entire intercepted arc would be a measure of 150. And then if I just remember that the inscribed angle will be half of that measure, half of 150 gives us 75 for angle B. And trying that again with a couple others, in circle O, we're trying to find measure of angle A. And this is always going to be a case whenever I am using an inscribed angle whose endpoints are on a diameter. That means I'm just intercepting a semicircle. So since a semicircle is always 180 degrees, half of that is going to be 90. So anytime that happens where I'm using an inscribed angle and the two endpoints are a diameter, the angle is always going to be a right angle. And we're using that rule again one more time to find four angles on part C. A, B, and C, and D. Yeah, so measures A, B, and C, and D. We're going to start with angle A, and it's the same rule for all of these really. Angle A has endpoints at B and D, so the intercepted arc between those has a measure of 100 and also a 90 added in. So if I add those together and divide by 2, because that's half the intercepted arc, that angle should be 95. Same idea for all the others. B is intercepting an arc that adds together 64 and 90. So if I add those together and divide that in half, that should be 77 for angle B. Same idea for C. That is intercepting an arc of 106 and 64 put together. So if I divide those by 2, I should get 85 for angle C. And for angle D, that's intercepting an arc that adds together 103 and 100. So if I look at half of that total, that should make 103. We've seen these rules a little bit before, but this is going to be corollaries that go along with that first page. Two inscribed angles that are intercepting the same arc are going to be congruent. And they're congruent because, again, if they're both half the measure of that intercepted arc, they're both half of that same arc. So those two will end up being congruent. Second corollary we saw on the last page, angle inscribed in a semicircle always got to be a right angle. Remember, a semicircle is 180 degrees, so half of that will be 90. And our third corollary is that opposite angles of a quadrilateral inscribed in a circle are going to end up being supplementary. The best way of thinking of that, so say for example, B and D are going to add up to 180, A and C are going to add up to 180, and we'll see why with some examples then towards the bottom. First part of problem 2, we're trying to find the measure of each numbered angle. In this case, it's just angle 1 here. In this, we're just using that second corollary, since angle 1 is inscribed in a semicircle. So that would just be cutting off basically half of your circle. Half of that semicircle, again, is just going to make 90. So anytime you see that, If my angle is using a diameter as its two endpoints, then half of that semicircle always going to be a right angle. And part B is using our first rule from up above. Angle 2 and this angle of 38 are both intercepting the same arc measure, so we don't even really have to find that arc measure. We just know that angle 2 will be the same as this 38. I don't know why I have a 78 there, but that should be 38 degrees for angle 2. Since they're both intercepting the same arc, those two angles should both be congruent. So 2 would be 38 degrees. And on our last one, we're using our last corollary, or also, I guess, kind of the second corollary. First of all, I found measures 1 and 3 first because they're both using the same rule. Since angle 1 and angle 3 are both intercepting a semicircle, that means that they will be half of that measure. So half of 180 is 90 again, kind of like that first problem that we did before. And then if we're trying to find angle 4, I found angle 4 first because we had a few measures to work with before we find angle 2. So finding angle 4, just like the last page, if I add together 60 and 80, that would be the intercepted arc. So half of that total should be 70 degrees for angle 4. And if we want to find angle 2, we're going to our last corollary. We're using our supplementary rule. If I have opposite angles, so angles 4 and 2 are opposite angles in this quadrilateral, that means that they should add up to 180. So if I already know that measure of angle 4 is 70 degrees, if I take 180 and take away that 70, that leaves us with 110 for angle 2. So that's using our third rule that opposite angles should be supplementary in my quadrilateral. So the measure of an angle formed by a tangent and a chord is also half the measure of an intercepted arc. So this is a case where angle C would not be an inscribed angle because my second side of that angle is not a chord. But as long as I have a tangent, so this would be a tangent and a chord, it's still basically going to be the same rule where I take the intercepted arc and I divide that by 2. And it's the same if your angle is obtuse or acute, so same idea. If I have a chord and a tangent, the measure of that angle is going to be half the measure of that intercepted arc. So let's try that with a little practice as well. In the diagram, we know that SR is a tangent line at point Q for a point of tangency. And we start with the fact that the arc PMQ is going to be 212 degrees. So starting from point P, going through M, and ending at Q, that part of the circle would be 212. And we want to use that to find the measure of PQR. So first thing we can do, there's actually a few ways we can work at this. What I did was I took 360 for the entire circle, and I subtracted the 212 that we start with. Because if we do that, we're left with 148 degrees, and that would be the measure of the arc that our angle's intercepting. Again, we didn't want SQP. We didn't need that angle that is intercepting the 212. We want the angle that's intercepting the other half of that circle. I say other half, but other part of that circle. So if this is 148 degrees and that's the intercepted arc for the angle that we're trying to find, I can just take that intercepted arc and divide that by 2. So half of 148 should be our answer. That's going to be 74 degrees. Again, so our rule from up top, whatever the intercepted arc is, our inscribed angle, or in this case not inscribed angle, but angle formed by a tangent and a chord, that's half of that intercepted arc. So also trying to get a few missing variables here. We want to find x and y. This one's a little bit easier to explain the diagram rather than add some equations in. So I'll explain my diagram here. First thing we know is that this angle QJL is going to be a right angle using our rule that as long as it's cutting off a semicircle as its intercepted arc, half of 180 is going to make 90. So I know that in this triangle that's set up, I have 35, I have 90. So we could actually find y first. I can just take 180, subtract those two, or also just 90 minus 35. And to complete that triangle, y should be a measure of 55 degrees. And you don't need y to get x. What we're using to find x is the fact that we should know the arc measure of JL. So this outside portion of the circle is going to be 70 because we're given 35 degrees is its matching inscribed angle. So since 35 degrees is the inscribed angle that is using the intercepted arc of JL, remember that should be half of that arc length, or half of the arc measure. So the arc measure is going to end up being 70. And if we know that the arc measure is 70, we're using that same rule from the top of the page to say that angle x is going to be half of that arc measure again. So it's kind of like what we've seen before with the same intercepted arc being used by two angles. As long as it's the same intercepted arc, those two angles should be congruent. So just like the 35 degrees was intercepting that 70 degree arc, x is also intercepting that 70 degree arc. So x is also going to be half of that. X is going to be 35. So make sure we have these down and we'll try some practice in class.